Today, we will learn about equivalent ratios. Rahul has 18 red marbles and 30 green marbles. Here, the number of green marbles is higher. Can you tell me how many times is the number of red marbles of the green marble? Think. Okay, let me tell you. Here, if we multiply the number of green marbles, that is 30, by 18 by 30, we will get the number of red marbles, that is 18. So, we can say that the number of red marbles is 18 by 30 times the number of green marbles. Or, we can say that the number of red marbles is 18 by 30 of the number of green marbles. Here, we have compared the two quantities like this. How much is one quantity of the other? Or, how many times is one quantity of the other? A comparison that tells us that one quantity is how much of the other or one quantity is how many times of the other is called a ratio. We express the ratio with a colon sign. For example, here the ratio of the number of red marbles to the number of green marbles is 18:30. This shows that the number of red marbles is 18 by 30 times of the number of green marbles. We can also express this comparison in reverse. Just like the number of green marbles is obtained by multiplying the number of red marbles by 30 by 18, we can say that the number of green marbles is 30 by 18 times the number of red marbles. That is, the ratio of the number of green marbles to the number of red marbles is 30:18. By looking at these two ratios, you must have understood by now that in a ratio, order is very important. Any ratio can be expressed in its simplest form. To do this, we first express the ratio as a fraction. For example, here we will express 18:30 as 18 by 30. Then we will divide the numerator and denominator of the fraction with the HCF of the numerator and denominator. Here, the HCF of 18 and 30 is 6. Dividing both 18 and 30 by 6 will reduce 18 by 30 in its simplest form to 3 by 5. Then, we express it in the form of a ratio. Just like 3 by 5 can be expressed in the form of a ratio as 3:5, 3:5 is the simplest form of the ratio 18:30. Here comes another important point. Ratios 18:30 and 3:5 both have equal values and are called equivalent ratios. Okay, is there only one equivalent ratio for 18:30? Think a bit. Let me tell you. If we write 18:30 in fraction form and then divide its numerator 18 and denominator 30 by 2, then we will get the new fraction as 9 by 15, which can be written as 9:15 in ratio form. Since both the numerator and denominator are being divided by the same number, the value of 9 by 15 will be equal to 18 by 30. This means 9 by 15 is an equivalent fraction of 18 by 30. Or, in terms of ratio, we will say 9:15 is also an equivalent ratio of 18:30. Similarly, in the fraction 18 by 30, if we multiply both 18 and 30 by 2, then we get a new fraction as 36 by 60, which is 36:60. This is also an equivalent ratio of 18:30. In this way, we can now say that a ratio can have many equivalent ratios. Now imagine you're given two ratios. For example, 9:15 and 6:10. Now compare these two ratios. First express them as fractions. For example, 9:15 becomes 9 by 15 and 6:10 becomes 6 by 10. Then, convert them into fractions with the same denominators. Since the LCM of denominators of both the fractions is 30, make the denominators of both the fractions as 30 so that their numerators can be compared. To make the denominator of 9 by 15 as 30, multiply both the numerator and the denominator of the fraction by 2. This will give us the new fraction as 18 by 30. Similarly, multiplying the numerator and the denominator of the fraction 6 by 10 by 3 will give us the new fraction 18 by 30. By doing so, both the fractions become 18 by 30. When the denominators are the same and the numerators also become the same, they are called equivalent fractions. Like here, 9 is to 15 and 6 is to 10 are equivalent ratios. Now let's compare 1 is to 3 and 3 is to 4. First, express it in terms of fractions, like LCM of denominators 3 and 4 is 12. So make the denominators of both the fractions as 12. 1 by 3 into 4 by 4 is equal to 4 by 12 and 3 by 4 into 3 by 3 is equal to 9 by 12. Here, 4 by 12 is lesser than 9 by 12. Notice that both the fractions are not the same. Instead, 4 by 12 is lesser than 9 by 12. Therefore, 1 is to 3 and 3 is to 4 are not equivalent ratios. If two ratios are equivalent ratios, then they're in proportion. For example, since 9 is to 15 and 6 is to 10 are equivalent ratios, they are proportionate and are expressed as 9 is to 15 is in proportion to 6 is to 10 or with a double colon. In any statement of proportion, four numbers are expressed in order. These numbers are called terms. Of these, the first and the fourth terms are called extreme terms, while the second and the third term are called middle terms. You must have now understood the concept of equivalent ratios. Can you think of some examples of equivalent ratios? Try it. Today, we learned about equivalent ratios. We will look at some examples in the next video. Today, let's look at some examples of equivalent ratios. Class 7 results of previous and current year of a school are shown in the table. Find out which year had better results. Stop the video and think about this. To find the answer, first take the ratio of the number of students who passed last year to the number of students who failed last year, which is 54 is to 6. Then, take the ratio of the number of students who passed this year to the number of students who failed this year, which is 63 is to 7. Now compare these two ratios. Any idea how? Absolutely right. To find out whether the two ratios are equivalent ratios or not, we express both the ratios in the form of fractions. For example, we would express 54 is to 6 as 54 by 6 and 63 is to 7 as 63 by 7. Now convert them into fractions with the same denominator. Here, we see that 54 can be divided by 6, which will reduce the fraction to 9 by 1. Similarly, 63 can be divided by 7 and will also reduce the fraction to 9 by 1. Now that the denominator is same for both the fractions, compare their numerators. Here, we see that the numerators of both the fractions are equal. Therefore, both the fractions are equal. So 54 by 6 is equal to 63 by 7. That is, both the fractions are equivalent fractions. 54 is to 6 is equal to 63 is to 7. Therefore, the performance of Class 7 last year and this year is the same. Ramesh covers a distance of 5 kilometers in 20 minutes. Find out what distance Ramesh would be able to cover at the same speed in 2 hours. We can find out the distance that Ramesh will be able to cover in 2 hours using the unitary method. In this method, we first get the value of 1 unit and then find out the number of units that we want from this value. To do this, first find out how much distance Ramesh covers in 1 minute. He covers a distance of 5 kilometers in 20 minutes. Therefore, in 1 minute he should cover a distance of 5 by 20 kilometers. That is, a distance of 1/4 kilometer. Now we have to find the distance he covers in 2 hours. Now 2 hours is equal to 2 into 60, which is equal to 120 minutes. So the distance covered in 2 hours is equal to distance covered in 1 minute, that is 1/4, into 120 minutes, which is equal to 30 kilometers. Therefore, Ramesh covers a distance of 30 kilometers in 120 minutes or 2 hours. Now let us solve this example using proportions. Since we know that the speed is the same in both the situations, the relation between time and distance is proportionate. That is, time in the first situation is to the time in the second situation is equal to distance in the first situation is to distance in the second situation. The time for the first situation is 20 minutes and the time for the second situation is 2 hours. But when expressed in terms of ratio, we will express it as 2 into 60 is equal to 120 minutes. Any idea why we're doing this? Absolutely correct, because in a ratio, the units of both the quantities need to be the same. So, in this ratio, the time of the first situation is 20 and second situation is 120. Similarly, the distance being covered in the first situation is 5 kilometers and we have to find the other distance. The ratio, when expressed as a fraction, would be 20 by 120 and 5 kilometers by the distance covered in second situation. To solve this, take the inverse of the fraction on both sides by swapping the numerator and the denominator with each other. 120 by 20 is equal to distance of the second situation by 5. Now either multiply both sides by 5 or take the 5 from the left to the right and change the sign from division to multiplication. Distance in second situation by 5 into 5 is equal to 120 by 20 into 5, which is equal to 30 kilometers. You must have understood how we can solve such examples with the unitary method and through proportions. Today, we have seen examples of equivalent ratios. In the next video, we will see misconceptions related to it. Today, we will look at misconceptions related to equivalent ratios. Misconception 1. The teacher asked the class, are 5:8 and 9:12 equivalent ratios? To this, Meera answered yes, while Manisha answered no. Who do you think was right, Meera or Manisha? We can write 5:8 as 5 by 8 and 9:12 as 9 by 12. You would think that just because 8 minus 5 is equal to 3 and 12 minus 9 is also equal to 3, the two ratios 5:8 and 9:12 are equivalent ratios. However, this is incorrect. So Manisha has got the right answer. Manisha has understood that the ratios have to first be written as fractions and then their denominators have to be made the same. In order to do this, take the LCM of 8 and 12, which is 24. So, the denominators of both of the fractions has to be 24. To achieve this, multiply the numerator and the denominator of the fraction 5 by 8 by 3 and 9 by 12 by 2. From this, we will get the new fractions as 15 by 24 and 18 by 24. The denominators of both the fractions are now the same, but the numerators are different. Here, 15 by 24 is lesser than 18 by 24. We can say that 5:8 and 9:12 are not equivalent ratios. Misconception 2. Which of these two statements do you think is correct? 18:36 is greater than 16:32, or 18:36 is equal to 16:32. It is wrong to think that since 18 is greater than 16 and 36 is greater than 32, 18:36 is greater than 16:32. Comparing two ratios in this way is incorrect. Hence, option 1 is incorrect. To get the correct answer, we have to convert both the ratios into fractions and make their denominators the same. 18:36 is equal to 18 by 36, which is equal to 1 by 2. And 16:32 is equal to 16 by 32, which is also equal to 1 by 2. Since the value of both the fractions is the same, that is, 18:36 is equal to 16:32, both the ratios are equivalent ratios. Hence, the correct answer is option 2. Hopefully, you have understood these commonly made mistakes and will not repeat them. Today, we saw a few misconceptions related to the equivalent ratios.